Hi, in this video we will demonstrate the work done in our DevOps course on two applications, iTrust and Checkbox.io. iTrust is a Java web application which uses a MySQL database and is hosted on a Tomcat server. We use Maven to build the application and run the test suite. The pre-deployment stages also include analyzing the test coverage and finding useless tests. In the deployment pipeline, an Ansible server configures a Jenkins server. This Jenkins server deploys the application in the application servers in a rolling or parallel update way. For the iTrust build configuration and deployment, we use different nodes for Jenkins and application server. We run the Ansible playbook to bring up the Jenkins server. Before deploying the application, we build the application code and run the test suite. To detect the effectiveness of test cases, we created a fuzzer for mutation-based random testing. We make random changes in the code by modifying strings and comparators and check if the test case is affected by it. Here we can see that after the fuzzing code is run, there are several test cases which are affected. After building the code, we configure the Jenkins server to push the code into production systems. Here we have two different jobs for a parallel deployment and a rolling upgrade of the application servers. From the console output, we can see that these jobs call an Ansible playbook to configure and deploy the production instances. The build jobs were configured to automatically invoke whenever we do a git push in the application code. Here, after doing a git push, the rolling update job will be triggered. We can see that a rolling update job has been triggered, and this job will bring up the application. Checkbox is a Node.js based web application hosted with an Nginx server. It uses MongoDB as database and Redis as a feature flag server. The pre-deployment steps include installing the dependencies and analyzing the code for code quality. In the deployment pipeline, an Ansible server configures a Jenkins server. This Jenkins server deploys the application in the application servers as a complete or canary release. There is a load balancer in place to distribute the traffic between the application server based on the release type. For Checkbox build configuration and deployment, we configure different roles for Jenkins server, application server with Redis master slave configuration, and canary release servers. We run the Ansible playbook to bring up the Jenkins server. The Jenkins job installs the dependencies and runs the code analysis tool. This tool checks for violation in server code quality, which includes number of conditions in if statement, function length, and complexity. To deploy the application, we have two Jenkins jobs here, one for release across all the servers and another for canary release. Upon successful build, an Ansible playbook deploys the code in application servers. We designed a Redis feature flag server which controls the availability of features in the application. Here, an attribute can create controls the creation of studies in the application. We implemented a simple load balancer which randomly assigns requests to the application servers. As you can see here, this load balancer uniformly distributes the traffic. For canary release, we implemented a load balancer which redirects just a fraction of traffic to the canary server. Here, an IP address ending with 167 is scarcely accessed because it is a canary release server. We have a timer in place which checks for errors in the canary release server and stops the redirection to those servers if any error is found. Similar to iTrust, we can also invoke a deployment using git push. For our fourth milestone, we integrated New Relic monitoring with Checkbox.io and generated flame graph to visualize and analyze the application stack trace. We installed New Relic infrastructure agent using Ansible scripts on relevant machines. The Checkbox.io application code was modified to include the Node.js agents. We also integrated AWS with New Relic to analyze AWS metadata. To generate the flame graph, we used the Linux perf event CPU profiler. We sample the data across the CPU, generate a perf report, and use it to create a flame graph SVG. This is a generated flame graph. Clicking on the stack, for example, here, and we can zoom in and analyze the stack traces. For example, here we can see that the stack accesses study.js, which in turn accesses the MongoDB module. And particularly, we can see that the MongoDB module invokes the find one operation here. This way, we can analyze the CPU stack traces.